So the other day, we had, the formula was 2.4 over cosine 35 plus 0.3 sine 35. So that's what I was telling you a minute ago. I was saying we had 2.4, 0.3. So I was saying change that to now using mu k, right? So this will tell you how much force is needed for constant velocity. And it should be, the answer is less than 2.42. Okay, what do you get there?
1.71.
F for constant velocity is 1.71, so that makes sense. So once it moves, you can maintain a force of 1.71 pounds, and it's still going to move at constant velocity. You see? I'm going to illustrate this with this chair here. So let's say I'm pulling here at an angle. Okay, it takes a certain amount of force to move, to first make it move. But then once, if I want to continue making it move at constant velocity, I can ease down a bit, right? But when I first want to make it move, I need to apply a little more force. So in this problem, you need to apply 2.4 pounds of force to make it move, but 1.7 pounds of force to move at constant V, once you move it, you see. And then the part D was asking what would happen if you pull with 1 pound more than necessary to make it move at constant V. So the F, it would be 2.71 pounds. And then part D, you would solve the same way as you would with, let's see, was this one, let's see, B, C, D. I believe this one is E, sorry. This is part E, right? The part D was saying what is the force needed for constant velocity, and then part E is what is the force needed if you, what is the acceleration if you pull with 1 pound more than that. So you go back now and you recalculate the normal force. Okay, you recalculate the normal force. So you can't use the same normal force that you had from part C, right? Because with part C, you were pulling with 1 pound more than 2.42. You were pulling with 3.42. So this one, you have to recalculate the normal force. So N plus 2.71 sine 35 is equal to 8 pounds. So you recalculate the normal force. Okay. And then now you do 2.71 cos 35 minus mu k times that, which is 0.2 times 6.45 equals ma, 0.25a. So you need to always be recalculating the n, because the force that you're pulling with has a vertical component. That's what this problem is trying to emphasize, grilling in you. you need to recalculate the n. And the other thing it's emphasizing is that once the object moves, never use mu s, always use mu k. Okay. Okay, now